KT 手刮木地板。
怀念的好滋味，围炉的好口味，补胜寿喜烧。
HTC One M9全球首发，即日起全台 HTC 专卖店盛大开卖。
保测瓶如何变身成吸湿排汗衣？球棒是利用仿形机裁切制作而成。
你什么样形状给它，它就跑出什么样形状出来。
传统药材如何运用西方技术做成科学中药？
台湾的酱，它是我们的命，也是我们的灵魂。
你不可不知的台湾制造大解密，星期一晚上10点就在 Discovery 频道。这个人能否骗过专家？这个人能否在球技、枪法和力气上赢过对手？他为了求胜不计代价，但他能否打败各领域的专家？即使他根本毫无经验。
It's going to be awfully close.
专家速成班全新系列4月8日星期三就在 Discovery 频道首播。
From the krill, the yarn travels through these tubes, across the ceiling, into the tufting machine. The tufting machine creates the actual carpet itself with high-speed needle strokes that sew the yarn into backing material. Hey, how are you? Fine, how are you? Good, that's how you shut this thing off, huh?
Oh, yeah.
Explain this machine to me. How does this work?
The yarn comes through the krill, through those tubes, around these rollers, into the needles.
Why does it have to go through this crazy maze to get to there?
To keep the same amount of tension on each strand of yarn. The needle takes it down, the hook catches it. The hook comes forward, and the blades cut it.
Do needles break? Do the hooks break? Blades, anything?
The most common is the blades getting dull or the yarn coming out of the needles, it's not cut.
Why does this mean the blade's dull? Because this piece of yarn's longer?
Yeah, it's not cutting the yarn right. So we have to get in there and change that blade. I took the dull blades out, and I got to put the new blades back in.
And the trick is to not cut yourself.
Right.
Ah! That scare you?
No.
How long do the blades last?
200,000 feet of carpet. On this machine, in 12 hours, I'll run 8,000 feet.
In 12 hours, you'll run 8,000 feet, and that blade lasts 200,000? So that's got to be
like once a month. This is the hook I showed you earlier.
Yep.
Okay, these blades have to go on the left side of that hook, like this. And then when you let it go, it puts pressure on that hook, and you have to tighten up the section.
So you got all the tension coming on each line, and you got pressure from the blades and the hooks.
In between these hooks, the hook gets the yarn. When the machine comes on, those hooks will go back. The needle will come down, the hook will catch the yarn. The hook will come back forward, and the blade will cut it.
I get it. Do you get it? The tufting machine creates huge rolls of carpet that have a variety of weave styles, pile heights, and densities. Each roll consists of about 900 feet of carpet or so. So what they do is they put it on the lift truck, and they bring it to this giant monster here. How you doing, sir?
Troy Beavers.
Troy, I'm Matt. Nice to meet you. What is this right now?
We're sewing 2 rows together and running them through a continuous dye range.
These rolls come from tufting. We need to sew them onto here so the continuous roll can keep going.
Right, before we can dye.
All right, how do we do that? I'm Matt, by the way.
I'm Mike.
Mike, nice to meet you.
You bring the new rolls in first.
Wow. What we're doing now here is we're butting these 2 seams together with this sewing machine.
Yes, push it down.
All right.
Okay,
Just kind of pull this out, kind of even with it, not too far. And it's supposed to make a flat seam when it goes through the dye line.
Oh, I got you.
It's kind of scary when you first do it.
I'd hate to come home like this. My wife say, babe, what happened? Well, I got my finger stuck in a sewing machine in Georgia. Well, we made some fantastic carpet. There you go.
And that's it.
That's actually pretty easy. I feel like a wuss that I was so scared of it.
Okay, you're gonna hit this one. Here she goes.
Not too fast?
No, just let it go,
And we're off and rolling. Now that it's sewn together, the carpet is ready for the next step in the process, dyeing. This is the dyeing station, right?
Right.
What's the most common color that people want their carpet? What do you see the most of?
Brown.
Brown?
Go ahead and do that.
Because as soon as I hit this button, the color is going to change right there. Look at that. At the heart of the dyeing process are huge vats filled with dye that are mixed and blended to produce almost any color imaginable. After the color's sprayed on at the dyeing station, the carpet goes through an intense drying process before being inspected. After quality control, the carpet is cut to size, bagged, and sent to distribution.
What we do is we consolidate all the carpet from our manufacturing facilities into this one location, and then we ship it throughout the world, and we also ship it to our other redistribution centers throughout the United States.
How big is this place?
Matt, this place is 1.5 million square feet, and we hold up to 24 million square yards of carpet in the facility.
24 million square yards of carpet? That's 1/6 the size of Rhode Island. That's enough carpet to cover the Rose Bowl 2,700 times. Is this Luis?
This is Luis, yes, Matt. This is Luis. He's our lead trainer. He's going to teach you how to drive this lift truck.
I hope you're good.
Oh, I'm good.
Right. Are you good?
I'm all right.
Ready? Hop on.
All right. So tell me, sir, what's my main objective here? What do I want to do?
Main objective is to learn how to get that pole into that hole.
Put the pole in the hole.
Yes.
My limited forklift education has given me just enough experience to be dangerous. Bingo! Not bad for a rookie.
That's it.
Now, all I have to do is make it back to the cutting station without running somebody over. Each roll of carpet has an identity like you and I. The color of my skin, my height, my weight, my name. This is the identity of the carpet. Each has a barcode, which is his name. The name tells the operator exactly which cut to make, how many feet, the height, the weight, the color of the carpet. And this machine moves so fast that it probably takes him anywhere from 30 to 45 seconds to cut up to 100 feet of carpet. The carpet cutter lines them up, cuts them, rolls them, wraps them, and shoots them down a half-a-mile conveyor belt where they're taken to trucks for shipping. Well, that's it. We've stitched it, sewed it, cut it, and dyed it. And here you have it. A brand new, fresh, ready to walk on, still enjoy it while it smells good carpet. Next stop, somebody's living room. Maybe even yours. Here in the plains of St. Augustine, New Mexico, there isn't much. A few mountains, a lone road, and a lot of desert. Oh, and 27 of the biggest antennas you'll probably ever see. This is the site of the VLA, or Very Large Array. It's a group of radio antennas that astronomers use to look deep into the universe. Now, the key word here is large. Each antenna is 82 feet across and weighs 230 tons. And they're spread out in a Y pattern that stretches about 28 miles. The VLA can probe the entire visible sky and known universe. And with it, scientists have looked at objects so distant they existed billions of years earlier than the formation of our galaxy. These images were created by computer analysis of electromagnetic radio waves emanating from space. The radio waves were received by the 27 antennas here at the VLA site and represent just a fraction of the discoveries made here since the beginning of operation in 1980. 27 antennas aimed at the same piece of sky from different angles duplicate the strength of one antenna 22 miles in diameter. This enables the detection of extremely faint radio waves, which are translated into digital pictures by a computer. The antennas are relocated 3 times a year, creating different configurations. Today, this 90-ton transporter and its 5-man crew will drive under this 10-story tall, $7 million antenna, disconnecting it from its concrete piers, and move all 230 tons of it to the new configuration position. Judy is the educational officer here at the VLA site. Look at that.
It's amazing.
Why do you need to put these antennas out in the middle of nowhere, in the middle of New Mexico?
First of all, we need to get away from the radio interference, like television stations and radio sources. And these little hills that ring us actually protect us. So this is a great place. Also, we can see 85% of the sky because of our latitude here in New Mexico.
So when you say 85% of the sky, you're talking about the entire
sky.
Surrounds
the entire sky that surrounds the Earth, yeah.
The transporter for this giant radio antenna was pointed in one direction, but it needed to travel in another perpendicular direction. How are they going to do that?
The wheels on this transporter are going to lift up and turn 90 degrees. What kind of a curve it would take to move this huge object if we wanted to take it and go down that way?
There are 4 sets of wheels on the transporter. Each set has 6 wheels. It takes about 35 seconds to turn each set 90 degrees, putting the transporter and the antenna on a different course. The VLA has 2 of these transporters. They were specifically designed for them, and they're the only 2 in the world. So as you can see, one of the antennas on the VLA is moving right now, and it's going at 3.5 miles per hour. And we're traveling 11 miles today, so basically this move is going to take anywhere from 4 to 5 hours. The scheduling of the move is weather dependent. Since the antenna dish is so large and wide, too much wind could easily topple it in transit. I'm here now with Dave Finley. Dave Finley is the Public Information Officer, isn't that correct?
That's right.
What are you expecting to see? What's it going to do, 11 miles away that it didn't do over there?
Well, the reason we change the position of the antennas is to get this zoom lens effect with the very large array. When we have the antennas spread out very widely, we can see a very small field of view in very great amount of detail. But when we bring them in close, it's like opening up that zoom lens. We can see a larger field of view and we can see larger structures.
What exactly are you seeing? Are you seeing pictures? I don't understand.
That's what the VLA does. The VLA makes pictures.
But there's not a lens on it, so how could that be?
There's not a lens. We're receiving radio waves instead of light waves. With light waves, you use a lens. With radio waves, you use a receiver. And just like your digital camera is really taking numbers and making pictures on the screen.
Okay.
And what we do is we get a bunch of zeros and ones, and we are able with computers to put them all together and make a picture of something out there in the universe that we're looking at. We have seen galaxies out to almost 13 billion light years from Earth, and that's just about as far as you can get in the observable universe.
That's unbelievable. And we need 27 of these things to do that?
We need 27 to make the high-quality images that we're making and to make them in a reasonable amount of time.
Yeah, I think it's huge. What's it made of?
It's made of steel and aluminum, and then, of course, has a lot of electronic equipment on the inside.
Nice.
And while we're waiting for them to move this 11 miles at this blistering pace that we just saw, why don't we go and look at one that's already on a set of pads and we can get a look at it.
All right, thanks, Dave. Let's go.
台湾新骄傲，海矿1400，上帝的配方，海矿1400，含丰富深海矿物质，有助于身体正常代谢。海矿1400的健康，身体最知道。台湾新骄傲，台湾 Yes 海矿1400，生命力，健康同步上市，请搜寻海矿1400。
KD 手刮木地板，
地表最强团队再创巅峰。Let's do this！ 玩命关头7， 4月1日抢先全美上映。
男人习惯武装自己，把勇敢当成保护色，却忘了温柔可以从容度过低潮，可以包容不知所措。温柔的无所畏惧。 才是最强悍的力量。温柔的强悍 ，Volvo S80。
S80 Drive D D4 雅致版，原价199万，限量179万。那是什么？
拜维嘉， 今天就靠它，老板会丢给我一大堆工作，1个小时后就要，还得跑去开会，主持重要简报，读业务报告，再和岳父母吃饭。重要的一天就靠拜维家。
Whoever governs Singapore must have that iron in him.
I am not here to play somebody else's game. I have a few million people's lives to account for. Singapore will survive.
保测瓶如何变身成吸湿排汗衣？球棒是利用仿形机裁切制作而成。
你什么样形状给它，它就跑出什么样形状出来。
传统药材如何运用西方技术做成科学中药？
台湾的酱，它是我们的命，也是我们的灵魂。
你不可不知的台湾制造大解密，星期一晚上10点就在 Discovery 频道。这个人能否骗过专家？这个人能否在球技、枪法和力气上赢过对手？他为了求胜不计代价，但他能否打败各领域的专家？即使他根本毫无经验。
It's going to be awfully close.
专家速成班全新系列4月8日星期3就在 Discovery 频道首播。
So right now, Dave and I are located about a quarter mile ahead of the antenna that's moving down the railroad tracks, and you brought me to this thing, and I'm tripping out because I didn't know that they moved.
They point. This thing can point anywhere in the sky, and that's what it's doing right now because we're moving from looking at one object in the sky to looking at a different object in the sky.
So who's moving it right now?
Right now it's being moved by computer, a file that was prepared by the observer who got the telescope time to look at something in the sky.
The telescope time. Okay,
Yes.
so you got to tell me, how does it all work?
This is open to any researcher in the world, and the way they get to use this instrument is to send us a proposal. And we have experts that we can send these proposals out to that review them. We call them referees.
All right.
And we get the comments back from the referees, and then we have a committee that schedules the telescope. And based on who got the best grades from the referees, that's who gets the telescope time. The VLA is one of the prime instruments in the world for studying the center of our own Milky Way galaxy, where we have a black hole that's about 4 million times more massive than the sun. And there are all kinds of interesting, neat things going on around that black hole. We look at other galaxies that have even bigger black holes at their cores.
So what's the big thing about a black hole?
Well, a black hole is a concentration of matter that's so dense that not even light can escape. And so you can't see it because you can't get any light out of it to see what's inside. The gravitation around a black hole is extremely strong. Material gets pulled in and it forms a disk. We call it an accretion disk. And that disk can get so hot from the friction inside that it puts out X-rays.
The question I would have is, what does that mean to us, our everyday lives? How is that bettering us? I know it's educating us in terms of what's out there, but how does that improve our lives?
Well, over the centuries, astronomy has improved our lives tremendously. Astronomy gave us the calendar that allowed us to move into agriculture from being hunter-gatherers. So it changed the whole face of civilization. It, in fact, made civilization possible. It gave us timekeeping. It gave us navigation to allow us to get across the deserts and the oceans. And today it's providing fundamental new knowledge about physics, about matter, about energy, about how they work.
While the antenna is being moved, the dish is in an upright position. When it is in position, the dish can be rotated as many degrees horizontally and vertically as needed, depending on the astronomer's observation agenda. The main part of the antenna is a parabolic dish, which is essentially a giant mirror made up of 172 aluminum panels. The radio waves from outer space hit the dish and are reflected up to a subreflector, which is a smaller dish. And then the signal is bounced down to a feed horn, which transfers it to a radio receiver housed in a small air-conditioned room under the dish. The signal is then transferred to the VLA computer lab.
So there she goes. After 11 miles, 3.5 miles an hour, and about 5 hours has passed, she's ready to move into place.
After the dish is lowered, this 5-man crew could have it secured and running in about 8 minutes. When the relocated antenna is powered up and linked with the others, it completes a new configuration. And a completely different field of view is available for analysis at the VLA's central facility. Radio astronomer Dale Frail is going to explain the process to me.
So a scientist would say the VLA is an interferometer, and what it measures is the spatial coherence function of the radiation field on the sky.
I don't know what that means.
I know. Okay. The simplest explanation is what these 27 antennas out at the VLA do is each of them measure the same piece of the sky. So all of those 27 antennas are looking at the same piece of the sky. And using the computer, we combine that information in a way that allows us to construct the image.
Wow, so can you just kind of show me what to do or how you do it?
Let's look at an image here. So here's an image taken with the VLA of the center of our galaxy. You can see the plane of our galaxy here. It's running up along this image here. And you'll see a very bright spot. That is the real value of the VLA, is you could take a look at that bright spot, for which you don't have a lot of detail in this picture, and say, I want to zoom up on that bright spot and see what's there.
Right.
And the process of discovery, you're going to find out what is at the center of our galaxy by doing that. So we go to our next image.
Dale is going to a closer image with the click of a mouse. But to see the closer images, 27 antennas had to be moved 3 times in a 9-month period. Just a little more complicated than the zoom on your camera.
Now you can see that bright spot is still not resolved out here. It's very bright.
Right.
But you start seeing all this beautiful structure of these kind of cirrus cloud-looking things.
So you can't see with an optical telescope because...
In an optical telescope, what you're not able to see past the dust and gas along the line of sight. It gets absorbed and radiated away. A radio telescope, because you're the longer wavelengths, can peer through all of this dust and gas and reveal the center of the heart of the galaxy. And so you zoom again. So now here's our third image. And in the red here, you can see a very odd-looking kind of creature.
Well, so now I'm thinking, okay, well, what's the red, right?
Exactly. And you go to the next configuration.
It's gonna be,
what's it gonna be? Now you're in, say, A configuration. Okay. And now that odd-looking pattern is seen much more clearly. It looks like a spiral pattern. It's probably caused by the tides near the center of our galaxy, this stripping of gas like this. And again, shown here in a bright white is another very bright spot that the telescope cannot yet resolve. That's down there at a very deep level in this zoomed-up image.
This is where we're at presently in time, right?
Yep, and I'll show you what little trick that we can do. You can actually now change frequencies a little bit, and down in here is, again, another unresolved dot. The brightest thing on that entire image is still unresolved by the VLA. And that we know from other methods, that this is a black hole. And this is the black hole at the center of our galaxy.
So I thought black holes, they're so powerful and they suck in all the light. Why is it white?
The white spot there is not the actual black hole itself, but there is gas falling in towards the black hole and feeding that black hole. And so it's probably from a disk around the black hole itself. So the black hole is unseen on this picture, but it reveals itself by the dust and gas that is falling into the black hole and feeding the black hole.
How far away is that?
25,000 light years away. Now, to put it in perspective, the light from our sun takes about 8 minutes to reach the Earth. So the sun is far enough away that the light travel time is 8 minutes. Here we're talking about 25,000 years for the light to go from there to there.
You know,
so the black hole could be undergoing a major eruption right now, and we would not know for another 25,000 years.
So let me ask you kind of like a selfish question, if I could. This stuff, it's great, we're finding out things, but what does that do for me as a husband, as a father, as my everyday life, just being a normal person? What does this do for me?
Well, it's not going to change the price of Brit.
Right.
To make these discoveries, you have to use the very best computers, the very best electronics, the very best imaging processing. And that finds its way into everyday life. Medical imaging technologies, communication technologies, things of this nature. Scientists are always pushing at the very edge of what you can do. This is just a fantastic time to be a scientist.
The fact
that these 10-story dishes are working in unison to actually see billions and billions of light years away is mind-blowing. Astronomy at its core is the reason our civilization exists as it does today. The calendar system, telling time, and now, thanks to the VLA, a deeper understanding of our planet's history and hopefully the future. See you in the heavens. I bet you guys thought I couldn't do a pull-up, huh? No, you're not supposed to show them. You just messed everything up. I hate when I get lint stuck in my pocket. You're very animated and like into this.
I taught sixth grade for a long time. That's why you and I get along real well.
What are you trying to say? I'm telling you, a sixth grader.
Whoever governs Singapore must have that iron in him.
I am not here to play somebody else's game. I have a few million people's lives to account for. Singapore will survive.
保测评如何变身成吸湿排汗衣。球棒是利用仿形机裁切制作而成。
你什么样形状给它，它就跑出什么样形状出来。
传统药材如何运用西方技术做成科学中药？
台湾的酱，它是我们的命，也是我们的灵魂。
你不可不知的台湾制造大解密，星期一晚上10点就在 Discovery 频道。
Britain is home to some of the most iconic dishes in the world. From fish and chips to steamed pudding, pie and mash to roast beef and Yorkshires. I want to find out why they're so deeply rooted in our culture.
So who's up first?
I'll be hopping into my time machine to explore their secret histories, looking for inspiration to create an epic culinary salute.
Let the feast begin.
周一换你煮赫斯顿英伦盛宴，就在 TLC 旅游生活频道。
想赚钱一点都不难，